and welcome to day 25 of our 30-day coding challenge from CS and Math. And we realized we haven't really gotten much into statistics and wanted to do a few days of that. We're going to cover indexing a list, mean and median mainly as the measures of central tendency, maybe mode, we'll see, and possibly standard deviation at the end. So go ahead and get set up in your Trinket or whatever you're running Python on, and let's get started. Now, the first thing is finding some data that kids will find interesting. So this is a historical one we've done, but there's other ones that have become more modern. So, for example, we want to say not only are we going to program statistics, but we want to do it to form an argument. So I always do almost like we do in a three-act task in the math class room. We try to, at stage one or act one, have the kids make a prediction or an estimation. In this case, though, they'd be predicting who do you think is the best home run hitter and why, like justify your argument. And then the second act would be like, okay, well, what would prove your point, essentially. So the first thing I want you to do then is to get the data into lists. Now, I was going to have us import this file. It's actually quite a bit of work though, so I thought it would be easier just to show you can, if it's not too much data, this is kind of on the edge, but you can just manually enter it in. So if I wanted to do, for example, Babe Ruth, I'm a lowercase underscore type of person, but you can import it any way you'd like. Just make sure you have square brackets and a comma separating each value. Now the year doesn't actually matter, that's just to kind of put context on what generation they were playing in. So 54, 59, etc. And I'll just pause it. I'll put this up, let it pause. Maybe I'll blow it up one more time. Pause right here and try to get that data in to your spreadsheet or into your list. Okay, so that probably timed, but to be honest, importing the data takes a little more time than I wanted to play with on this video, maybe on a future one. But usually what kids argue are things like what you'd expect from year to year is really important. Like how is their average comparing? Like what's their measure of center? They might argue things like consistency. Were they consistently on the high end of home runs, or were they up and down? And we could talk about standard deviation in that statistic. One thing that kids always bring up is longevity. That's extremely easy to do, so I thought I would just run this first one with you. And notice how, I think I already ran it before this, and it says it prints Babe Ruth 15 years. And they would argue, well, Roger Maris didn't play long enough. So if I did print len is length, command for length, so Roger Maris, I run this, only played, I guess it was 7 years. So then they could talk about, well, is there a threshold we want to say you have to play for at least this long, longevity-wise? So go ahead and run the other two and make sure you have that function working. So yeah, right off the bat, kids might say, well, these three players can be in the debate, but Roger Maris played less than half as long as the other three. So let's throw him out. The only reason he's even in the debate is because of this year with the 61. But those are good conversations, and again, they involve statistics, so that was a good place to start. Another good place to go that's fairly easy, but very important in running programs is figuring out average, or even median. So go ahead, and I'm going to give you an opportunity to see if you can think about how might you code that. And I'll come back here in a second and talk about how we do it. Okay, so a couple things. First, if you ever want to just turn off part of your code, you can put 3 quotations around the block of code you want to turn off, and notice how if I do that, that part turns red in this particular environment. And then up here I've added, this is a comment, remember, let's move that over, but this is how you index or access stuff from the list. So if I say I want Babe Ruth's first number, notice if I run this, it prints 59. Recall in some previous videos we talked about 59 is the first term. Python always starts with a 0 term. So if I change this to 0, then we could get it to access that first year. Okay, and then you would want to try to get access to all of those and kind of have a running total or tally them up. So I could add in here like total and just initiate it at nothing. And again, if you didn't know what to do, maybe now you could pause again and think. But we will definitely show you step by step. Okay, so for consistency, we started the total out. Now, one thing you might have thought to do was say, okay, well, we need to loop this, right? So that each time is going to take like 54, add 59, and so on in your brain. And so we can use different types of loops. I'm going to use a for loop. So the standard way to do this is to say for I, for item in range. We said he played for 15 years, so we'll do 15 there. And we'll say, oops. Let's just try to first index or access this first home run number. And to keep it simple, like a small or a shorter variable, let's call it HR. So I would want to access Babe Ruth like we had it before. But this time, instead of typing in a 0 or a 1 there, I'm going to type in I, which actually revolves. So just to help you see this, I could always just do a print. I could print that I in case you didn't know how that worked exactly. Notice how it prints 0 through 14, so 15 numbers that wrap through there. So this number is going to be first 0, the 54. Then it will be 1, which is the 59. Then 2, which is the 35, and so on. So this number will change to the yearly home run. And then what we want to do is take the total, and we initiated it here, but we want to reassign it. We want to reassign it a new value that was the previous total, whatever that was, plus this new yearly home run value. And then instead of printing I, because we already know what that is, we're going to print the total at the end. Now this would be in the loops. If I ran this, this would be printing the running total kind of year to year. If I took it out of the loop, then we would print just the value at the end. And what I realized here in search, I don't know if you saw it at the top of my screen here, but I realized, wait a minute, I know Babe Ruth had more home runs than that. So I've never actually ran this with Python. We always did this with Excel in our classes, and I've run it in AP statistics. I ran it in algebra for histograms and different things. Never realized that data was not accurate. So whoever made this chart for our school, they skipped some years. So maybe they had some bias in there. They didn't put these first 1, 2, 3, 4, 5, 6 years are missing from that data set. And then a year at the end where you only hit 6. So I would have to cross-check this. I don't think that this was whoever made this chart, I don't know why they did this, but it's the first time I've ever realized it. But it's still good to do, right? Good to know. So I started to Google, well, how would, I want to verify that was the actual amount of home runs that he hit to make sure I'm doing this right. Part of the verification step. So go ahead and see if you can't write one of these for, let's say, Lou Gehrig. Okay, I just thought I'd pop in here. If you've already written the other one, see if you can write something similar to this for Lou Gehrig. So I've went back in and I just couldn't handle the off numbers. Just the false statistics really get to me these days. So I put in all the years. So Babe Ruth actually played 22 years. And notice I changed that. Instead of just writing in the 22 for how many times we want to repeat, we can actually make that something that's variable. Something like the length of Babe Ruth or the length of any list, really. And yeah, so right there we have Ruth played 22 years and indeed hit 714 home runs. So I'm going to pause and write that for. Okay, so we just copied and pasted, right? And we just, wherever you saw Babe Ruth, just posted in the name here, Lou Gehrig. Looks like if we did the length of Lou Gehrig, he played 17 years, 493 home runs. We verified that was correct. I wanted to make sure this time, so that is good. Found those statistics online, and what you might have noticed here is that this kind of fits a mold, right? We're just going to keep copying and pasting the same mold of code for each person. So that's a telltale pattern that you want to write a function for that pattern so that you can make your code concise and then usable wherever you want. So let's show you how to do that. So even though we've done this in previous programs, let me remind you that the definition then is DEF. So to define a function, we say the definition of average home runs, we'll call it maybe, average HR. So average home runs, we'll put no parameter in there for now. I'll show you how to do that in a second. And just say average home runs takes in nothing. And then remember, in order to be inside the function, we have to tab it in. And then so we have to tab it in so that it stays within the definition. And then after we've defined it, then we have to actually call it. So I'd have to call average home run. So I'd call average HR. So this right remember is a call, whereas this is average function definition. And if we run this, notice how we get 22 and 714 again. Okay, so make sure you got that working, and I'll show you how to put that parameter in there. Okay, so just like we could use a variable as a parameter, we certainly could use a list as a parameter. So I'm just going to say this is going to take in a list, and instead of this being Babe Ruth, wherever I see that word Babe Ruth, I'm going to or that list Babe Ruth, I'm going to take this and paste it in. So I'm going to say, yep, that should be good, and then this would become list. And then when I call it down here, I have to make sure that I say, in these are the parameter or argument that you're trying to take in. We want to take in Babe Ruth's numbers. And I could call that function. Nothing happens because it's going to do the same thing. But then remember, if I want to call average home run for Gehrig, now I would pass in a different list. Okay, and then to make this look good, you could always put a print statement in there saying like the character first. So I'm going to pause and do that. Why don't you just write the last two people, and we'll kind of take a look at that here in a second. Okay, actually, we better finish this up. I just looked and saw we were up there pretty high on time. So obviously, we're just doing a total now. Let's finish off the average and save the rest maybe for a video tomorrow. Notice that I have all the years and totals here. So I'm going to now just, I don't want this in the loop. I want to do this after. So at the end, when I've totaled everything up, I want the average to equal. So notice that one tab. Kids will often find this to be an issue. Like one indentation can mess everything up. But we're going to have to use the total that we got and divide that by the length. Now we actually put in list because we're passing different lists through here. So we want to take the total, divide it by the length of that list, and that should be the average. Let's for now get rid of the total and just print the average. So it should say the number of years and the average. And that looks pretty good. So yep, 714 divided by 22. This looks accurate. And what I can do here to finish this off for today is say, first of all, I don't like this. I want it to be rounded to the nearest whole. So I'm going to say round this. Average just to the nearest whole number would be fine. Run that. Or if you wanted, you could do a decimal or two. Let's say you want to round that to 2 decimals. So we can put that second parameter in the round command. So that will round that out. And then, you know what, I do want the total printed in there as well myself. So I'm going to print the length of the list, which is the number of years they played, the average and the total. And so that would look like this. So now we've got a central tendency and a total, longevity, and measure of center have been covered, and we'll spill the rest into tomorrow. Sorry that took so long. I ran into some stuff I didn't really think through fully. And hopefully it was still good, though. I liked abstracting this out and making this a function, which I hadn't planned to do. So thank you guys so much for watching, and we'll catch you again tomorrow. Thanks.